Hey, hello, how are you? And welcome to Chapter 5 of my C++ tutorial. And before we get into anything new, I just want to run over last video's homework and the solution to it. So over here, I have the exact code sample that I uploaded to Pastebin and put in the description. It's the formula to convert Celsius to Fahrenheit, and then outputting Fahrenheit, of course. And your task was to switch this around, so instead of generating the Fahrenheit value, you generate the Celsius value from Fahrenheit. So right off the bat, there's a few things we need to do if we're going to accomplish this. So instead of initializing Celsius, we're going to take that out, and we are going to initialize Fahrenheit instead. We're just going to keep it as the default, as 0. Since we want to output Celsius, we need to change the Celsius calculation there, and we need to change it in our output statement. And since we are dealing with Celsius, we want to calculate from Fahrenheit. So all the variables are now changed up, all in place. So now it's just a matter of switching around this formula so that it will work in the exact opposite direction. So if you have any basic math skills from junior high or middle school or high school or whatever, any basic algebra, you should know how to isolate for different variables. So instead, the formula is going to look something like this. If we just start simplifying or isolating, it'll look like this. And then you divide... use comments. F minus 32 is equal, divided by 9 over 5 is equal to Celsius. So that should be our final formula. Sorry if you hear my dog down there just barking around. So time to just start swapping this guy around. So I'm just going to cut this out for now. Keep it on my clipboard. We want to change this to a minus, and you see here, to satisfy order of operations, I have this in brackets. So we are going to add brackets around that, and then divide the whole thing by 9 over 5. So I can save that, and I can run it, and hopefully it will work. Yep. And if I change this to 20, get negative 6 point something. Yeah, exactly. So this is my working code sample here. This is the solution. I will upload this in the description as well. There's a few things that I wanted to note here. Although, you can observe over here, I'm casting the integer 9 to a float value, but what exactly is a float value? If I output that, what do we get? Well, I get 9, sure, but in C++ or most programming languages, any float value is essentially just anything with like a 0.0 after it. That's essentially what casting the integer does. So we could change these around, and instead of doing float 9, we could just put in 9.0. And that'll make our code look a lot more readable. So I'll save that, no problems, run this, and you still get the same output. So if that's working, that's all fine and dandy. There's one more thing I wanted to cover, because we did do casting, but the char value is drastically different than an integer or a float. It represents an actual character instead of a number. Or does it? You see, just using this statement over here, I can do something like just a regular character A, for example. If I output this as is, sure enough I should get an A, which is exactly what I get. But what if I cast this to an integer type? If I run this, you'll see I'll get a 97. Because, as I mentioned before, I have an ASCII table right over here, you'll see that the character A is represented by the decimal 97. So the value I'm getting here is the actual numerical representation for that character I just outputted. So if we go back to Visual Studio here, now I want to start getting into some of the newer stuff. So I will wipe this out of the way for now. We're going to be looking at arrays. Arrays are basically just a fancy way of saying a list, like a shopping list. And that's the analogy I'm going to be using actually. So on your shopping list you have like, you say want to get like eggs, bread, butter, whatever. In C++, well, we haven't dealt with longer like strings of letters and stuff like that. So we're just going to be using numbers for this example. So we could just say like int array equals, what did we want to do? Like let's add 3 things to it. 1, 2, 3. But you see we're already going to get some errors here. Expected identifier. If I try to run this, it's not going to work. Yeah, see, I'm getting build errors, and yeah, I don't want to run that. It's just going to try and find the last working thing. Yeah, I'm getting errors down here, all sorts of things. So instead, what we want to do is use a special notation when we're creating an array or a list, and that is we just put 2 little square brackets after the name of the identifier. But you see, we're still getting an error, and now the whole thing is just screwed up, right? Like even that one that wasn't there before, and that's because we need to add even more notation to this. When we're creating an array and we're already initializing the values with it, we put this in curly braces. So essentially hitting shift with your square brackets there. So if I save this, it should work. And I'm not going to output this right away because there are some more problems with it, or stuff that I haven't covered. So save that as is. And there's another way to do this, but, or as you know, you can either initialize a variable when you're declaring it, or you can just declare it and leave it blank. So if we were to try to create a new array, and we just put a semicolon after, as is, you see we're getting an error again. Incomplete type is not allowed. And why is this incomplete exactly? Is because when you're creating an array in C++, just basic array, no vectors, no other fancy things, you need to create a size with it. And that's because when you are creating an array, the computer needs to know how it's going to allocate all the memory for it. And if you're creating it like this, it sees there are 3 things in the array, so it's going to allocate 3 of however many bytes this would be. So 4 bytes, I believe, by default. If we take it out, it has no idea how big to make that array, how much to allocate. So we have to add our size there. If we save that, that should work. And you see no more error. If I were to run this, it would work perfectly. I'm not going to because you won't be able to see what's going on behind the scenes yet. And if we're trying to pull a value out of an array, we use those square brackets. Let's say we're working with the first one because it already has values. Let's say I wanted to pull the 2 out. The 2 is the second value in this array, so we put the number 2 in the square brackets, except you're going to see there's another problem with this. If we try and run it like this, you see we're going to get 3. And that's because when we learn more about memory management, this will make sense, but the computer starts counting the array from 0. So 2 is the third number from there, 0, 1, 2. So it's looking at the third value, 3. And that's why it's outputting a 3 there. So if we change this to a 0, for example, we should get 1 here. If I run this, 1. Perfect. If I add a 1 in its place of that 0, we'll get 2. So that's how we pull the second value out. This is just really, really basic array fundamentals. We're going to go way more in depth with this later. You can add whatever you want, whatever kind of data type you want to your array. You can add more complex data structures, or we could do this with characters. So if I do this, of course we need to use our notation. Save that, ABC, and pulling out the second value because we have a 1 over here, you'll see we get B, because B is the second value. And that's basically all you need to know about arrays for now. We'll be working with them more in the next video, and just later on in general. So have at it. One more thing is that if you just try and print the entire array, you're going to run into a problem with this. See, we're getting all kinds of other things here. Don't mind this. This is just a Japanese localization that I have on my computer. So you're going to just... You might get this, you might get something else. Yeah. It's because it's reading like all kinds of other stuff in memory. So don't worry too much about it for now, and I will see you in the next video. Cheers.